Comparing numbers in C++ to determine their relative order is essential for tasks like sorting, searching, and decision-making in algorithms. C++ provides several operators for this purpose, including equal, that is equal to, and exclamation equal, that's not equal to, and less than, greater than, less than or equal to, and greater than or equal to. Boolean expressions are the building blocks of decision-making in programming. They evaluate to either true or false. So these are expressions that use comparison operators like greater than, less than, equal, exclamation equal, less equal, greater equal, to compare values. In here we have an example. 12 greater than 5 evaluates to 2 because 12 is indeed greater than 5. 7 less or equal to 5 evaluates to false because 7 is not less than or equal to 5. And we also have variable-based example. So if x is 10, then x equal 10 is true. X exclamation equal 8 is true. X equal 8 is false. Boolean expressions don't just have to be used in control statements. You can also assign their results to variables for later use. You can store the result of a Boolean expression in a variable like this: result equal x less equal to y. In C++, true, T-R-U-E, is represented by 1, and the false is represented by 0. So if x equal 5 and y equal 10, then result equal x less or equal y would assign 1 to result. Because x is 5, y is 10, and x is less or equal to y. So x less than equal to y evaluates to 2, which is 1, and this 1 is assigned to result. So don't confuse equal and double equal. Equal is an assignment operator. It assigns the value on the right to the variable on the left. Double equal is a comparison operator. It checks if the value on the left is equal to the value on the right. What does conditional execution mean? It means that the certain blocks of code will only run if a specific condition is met. Otherwise, they will be skipped. Think of it like making decisions based on the weather. If it is raining, take an umbrella. If it is cold outside, wear a coat. So this is the flowchart of the decision. We evaluate, is it cold outside? If it is true, we wear a coat. If it is false, we do nothing here. This is another example. If it is outside is a cold, we have multiple actions. We wear a coat, wear a hat, and wear gloves. Otherwise, we skip all those actions and does nothing. The if statement is one of the most fundamental constructs in C++ for conditional execution. It allows your program to make a decision based on Boolean expressions. The basic syntax is quite simple. If, and you have an expression in the round parentheses. Then under that, you have a statement. So here, expression is a Boolean expression that evaluates to either true or false. The statement is the code that will be executed if the expression is true. the expression inside parentheses must evaluate to a Boolean value. For examples, x greater than y is raining or is valid, etc. So if the expression evaluates to true, the statement is executed. If the expression evaluates to false, the statement is skipped. This is useful for making decisions in your code. For example, checking user input, validating data, or controlling program flow. We are looking at a C++ program that calculates the average of 3 test scores and conditionally congratulates the user if the average is high. The program includes the I/O stream for standard input-output and the I/O manip for formatting output. Using namespace std is used for convenience. 3 integer variables, score1, score2, and score3 are variables to hold the test scores. The average is a variable to hold the calculated average. Is declared as a double type. The program prompts the user to enter 3 test scores, which are stored in score1, score2, and score3. The average is calculated as score1 plus score2 plus score3 inside parentheses, then divide by 3.0. Note the 3.0 is to ensure floating point division. The fixed show point and the set precision 1 are used to format the average to 1 decimal places. An if statement checks if the average is greater than 95, and if so, congratulates the user. So this program demonstrates user input, arithmetic operations, output formatting, and a conditional statement. Here's a flowchart. If the average is greater than 95, if it is true, display congratulations. Otherwise, if the condition is false, we skip this congratulation and we do nothing. Do not place a semicolon immediately after the expression in an if statement. Doing so will terminate the statement, causing unexpected behavior. For example, if you place a semicolon, if score greater than 90, then you have a semicolon there. So it will terminate this if statement. The grade equal to A will be executed anyway, no matter the condition is true or false. And you place the statement on a separate line, indented for better readability. So grade equal to A is placed in a separate line, indented from the if statement condition. And be cautious when testing floating point numbers for equality due to precision issues. Using a small tolerance range instead. For example, if x equal 3.14, that's pretty risky. Instead of this, we can use the absolute value. So if like ABS is a function call to absolute value. ABS is included in the CMass header file. So if ABS, then inside the parentheses you say x minus 3.14. If this ABS is less than 0.0001, so it gives a range. In C++, 0 is considered false, and that any non-zero value is considered true. When you need to execute multiple statements conditionally using an if statement, you can enclose them in curly braces to create a block of code. Curly braces define a block of code that shall be executed together. So in this example, if score is greater than 90, you have two statements here, grade, you assign A to grade, and you also see out good job. So those two statements are enclosed in curly braces, so they will be executed together if the condition is true. The if-else statement allows for two distinct paths of execution based on a condition. It is like a fork in the road. You go one way if the condition is true, and another way if it is false. If the expression evaluates to true, statement 1 can be a single statement or a block of code, is executed. And the statement 2, which also can be a single statement or a block of code, is skipped. So if the expression evaluates to false, statement 1 is skipped and the statement 2 is executed. We are looking at a C++ program that uses the modulus operator to determine whether a given integer is odd or even. So inside the main function, we have an integer number declares an integer variable to store the user's input. The program prompts the user to enter an integer, which is stored in the variable number. The modulus operator returns the remainder of the division. Number modulus 2 will be 0 for even numbers and 1 for odd numbers. The program uses an if-else statement to check the result of number modulus 2. So if the number is even, it prints this number is even. And if the number is odd, it will print the value stored in the number, then say is odd. So the number modulus 2 equals 0 will be evaluated. If it is true, the number is even. If it is false, the number is odd. This program performs division of two numbers, num1 and num2. Importantly, it checks for division by 0 to prevent errors. So there are three double variables, num1, num2, and the quotient are declared to hold the numbers and the result of the division. The program prompts the user twice, once for num1 and once for num2. So before performing the division, the program checks if num2 is 0. So if num2 is 0, a warning message is displayed. Otherwise, the quotient is calculated and displayed. So this program demonstrates the importance of input validation, especially for operations that can result in errors like a division by 0. Nested if statement allow you to test multiple conditions in a hierarchical or sequential manner. An if statement inside another if statement is known as a nested if statement. Here is one example of flowchart of a nested if statement. So if employed equal y, if this expression evaluates to true, then we have another condition if recent grad equal y. If recent grad equal y is true, we displayed you qualify for the special interest rate. If it is false, we display you must have graduated from college in the past 2 years to qualify. And if in the case if employed equal y, if it is false, we display you must be employed to qualify. This piece of code are in program 410. The program used two variables employed and the recent grad. Those are in the captured data type, CHAR data type. Those two are to hold the user's employment and the graduation status. So these variables are checked to determine if the user qualifies for a special interest rate. The inner if statement is nested within the outer if statement. The inner if statement, recent grad equal y, is only evaluated if the outer if statement, employed equal y, is true. If both conditions are met, the user is informed that they qualify for a special interest rate. So the nested if structure ensures that the recent grad is only checked if employed is y, making the condition dependent on each other. This piece of code is from program 411. The program first checks if the user is employed. By employed, evaluate employed equal y. If employed, it then checks if the user is a recent graduate by evaluating recent graduate equal y. So based on these conditions, appropriate messages are displayed. The program handles three scenarios: employed and a recent grad, so that qualifies for a special rate; employed but not a recent grad, it needs to be a recent grad to qualify; and not employed, so must be employed to qualify. Proper indentation is not just a matter of style, it is crucial for readability and maintainability, especially when working with if-else statement. So indentation helps visually separate blocks of code, making it easier to understand the program's flow and the logic. In nested if-else statements, indentation becomes even more crucial for understanding the code structure. The outer if-else go together, and also the inner if-else go together. The if-else chain allows to test a series of conditions sequentially until one is found to be true. It is often simpler and a more readable alternative to nested if-else statement. Conditions are evaluated in the order they appear. As soon as one condition is true, its corresponding block is executed, and the rest are skipped. This example models a simple thought process about what to take based on the weather. If it is raining, you take an umbrella. Else, if it is windy, you take a hat. Else, you take sunglasses. If-else allows for sequential evaluation of multiple conditions. So each expression is a Boolean condition that is evaluated in sequence. Statement 1, Statement 2, Statement N are the corresponding code blocks for statements that get executed if their respective conditions are true. So the conditions are checked in the order they appear. The first true condition's corresponding statement or block is executed, and the rest are skipped. This section of code are from program 413. This example demonstrates how to use an if-else chain to assign letter grades based on a test score. The program uses constants like A score, B score, etc. to define the score thresholds for each grade. Test score is the variable that holds the score to be evaluated. The program checks the conditions in sequence. The first condition that evaluates to true will execute its corresponding statement, and the rest will be skipped. The conditions are designed to be mutually exclusive and are checked in descending order of grades. This ensures that only one grade is assigned. Program 414 does a little more. The last else statement catches any invalid test scores. For example, scores are not in the range, like a negative score. And then it outputs an error message for any invalid score. A flag variable is used to signal a condition or status in a program. Flag variables are usually implemented as a bool variables, B-O-O-L, but they can also be integers. When using bool, the variable true and false are used to indicate the condition. So when using an integer as a flag, the value 0 is considered false, and any non-zero value is considered true. Like any other variable, a flag variable must be initialized before it is used to avoid undefined behavior. In this example, isUserValid is a flag variable that signals whether the user is valid or not, and we initialize it as a false. So flag variables are useful for tracking states or conditions that may be checked multiple times or in different parts of a program. Logical operators are used to create complex rational expressions by combining simple ones. The primary logical operators are AND, OR, and NOT. The logical AND, it means both conditions must be true. If both the operands are true, then the condition becomes true. For logical OR, meaning at least one condition must be true. So if any of the two operands are true, then the condition becomes true. For logical NOT, meaning it converts the value of a condition. It is used to reverse the logical state of its operand. We will look at how to evaluate complex logical expressions using variables and the logical operators. Integer x equal 12, y equal 5, z equal -4. So three integer variables x, y, and z are initialized with the value 12, 5, and -4 respectively. The expression 1 inside the round parenthesis, x greater than y, then and, which is a logical AND, then after that it's a y greater than z inside the round parenthesis. So the evaluation for the x greater than y, it is true. Y greater than z, it is true. So true and true, the result is true. Both conditions are true because 12 greater than 5 and 5 greater than -4. So the overall expression is true. The second one, x greater than y and z greater than y. So the first condition is true because 12 is greater than 5. But the second condition is false. The -4 greater than 5 is false. So making the overall expression false. The third expression, x less than or equal to z, which is 12 less than or equal to minus 4, which is false. And the y equal z, which is 5 equal minus 4, is false. So the overall expression false or false is the false. The result is false. The false expression 12 less than or equal to minus 4 is false. But the second one is true, which is y not equal to z, which is 5 not equal to minus 4, which is true. So making the overall expression false or true, the result is true. The expression 5, not, and inside parentheses, x greater than or equal to z. So this condition, x greater than or equal to z, is true because 12 is greater than or equal to minus 4. But the not operator inverts it to false. This section of code is from program 415. It demonstrates how to use the logical AND operator to determine a user's loan qualification based on multiple conditions. The program used two character variables, employed and recent grad, to hold the user's employment and graduation status. The program checks both conditions, employed equal y and recent grad equal y, using the AND operator. The message about qualifying for a special interest rate is displayed only if both conditions are true. If either or both conditions are false, the program informs the user about the requirements to qualify for the special rate. This section is from the program 416. It shows how to use the logical OR operator to determine a user's loan qualification based on either minimum income or years of employment. The program used two variables, income and years, along with two constant, mean income and mean years, to evaluate the loan qualification. So the program used the vertical two double vertical bar, which is an OR operator, to check either of the conditions, income greater or equal to mean income, or years greater than mean years. The user qualifies if either of these conditions is true. If neither condition is met, the program informs the user about the minimum requirements for qualification. This is from program 417. This section of code uses the NOT operator to invert the result of the OR condition, income greater or equal than mean income, or years greater than mean years. So if neither condition is met, the NOT operator will make the if statement true, and the user will be informed that they don't qualify. In the else block, if either of the condition is met, the else block will execute, indicating that the user qualifies for the loan. Among logical operators, NOT has the highest precedence, followed by AND and then OR operator. Knowing the precedence helps in avoiding intended results, especially when multiple logical operators are used in a single expression. Logical operators AND and OR use short-circuit evaluation. This means if the result of the entire expression can be determined by the left-hand operand alone, the right-hand operand will not be evaluated. For example, in the AND operator, if the left operand evaluate to false, we can immediately determine this expression is always false. For the OR operator, if the left operand is evaluated to 2, so 2 or anything will always be 2. Logical operators can be used to test if a value falls within or outside of a specific range. So use the AND operator to check if a value is within a range. Here, the grade is considered valid only if it is between 0 and 100 inclusive. Use the OR operator to check if a value is outside a range. In this case, the grade is considered invalid if it is less than 0 or greater than 100. C++ doesn't support mathematical range. This syntax is incorrect and will not produce the expected result. A menu-driven program allows the user to control the flow of the program by selecting from a list of actions. The user selects an option, usually by entering a number or character, and the program performs the corresponding action. If-else-if statements can be used to evaluate the user's choice and execute the corresponding block of code. This program 418 demonstrates a menu-driven application for a health club membership. It uses if-else-if statements to handle the user choices. The program uses integer variable choice and a month and the double variable charges to hold user input and calculations. Constant like adult, senior, and the child are used to store membership rates. The program starts by displaying a menu of choices. The user's choice is captured and stored in the variable choice. The program sets the numerical output to display 2 decimal places. The if-else-if block evaluates the user's choice and performs the corresponding action, such as calculating charges based on the number of months. Here we have an adult choice or child choice or senior choice or quit choice. If the user enters an invalid choice, the program informs them of the valid options. Input validation is the process of inspecting user input to ensure it's acceptable before using it in calculations or operations. It is a crucial part of any robust application. So bad input leads to bad output. Input validation helps in maintaining the integrity and the reliability of a program. It ensures the input falls within a specific range. It can check if the input makes sense in the given context. It validates if the user's choice exists in the menu options, and ensures the denominator in a division operator is not 0. This program is from 419. It demonstrates how to validate user input for test scores and then determine the corresponding letter grade. First, the program captures the user's test score and stored it in the variable test score. Before determining the letter grade, the program validates if the entered test score falls within a predefined range, from minimum score to maximum score. If the input is valid, the program uses a series of if-else-if statements to determine the letter grade. So if test score greater or equal to A score, we see out your grade is A. Else if test score greater or equal to B score, we see out your grade is B. And similarly, use all the else if for C and the D score, and the last else is for the grade is F. If the input is invalid, the program informs the user about the acceptable range for test scores. This is in the else block, see out. This is an invalid score. Run the program again, enter a valid score range in the range of a minimum score through the maximum score. In C++, characters are compared using their ASCII, American Standard Code for Information Interchange values. This is important to understand when working with conditional statements involving characters. Each character has a corresponding ASCII value, which is an integer. For example, the ASCII value of capital A is 65 and the B is 66. So the capital A is less than capital B. Here, capital A is less than capital B because the ASCII of capital A, which is a 65, is less than the ASCII of capital B, which is 66. Numerical characters are also compared based on their ASCII values. Here we see the 1 and the 2, they are enclosed in a single code, so they are kind of characters. The ASCII value of 1 is 49 and the 2 is 50. The lowercase letters have the higher ASCII values than uppercase letters. For example, the ASCII value of lowercase a is 97, which is greater than the ASCII value of uppercase Z, which is 90. This program demonstrates how to use rational operators to compare characters based on their ASCII values. First, we have a cout, enter a digit or a letter, and ch is equal to cin.get. So the program prompts the user to enter a digit or a letter and capture it using the cin.get function. Then the program uses a series of if-else-if statements to determine the type of character entered based on its ASCII values. So this checks if the ASCII values of the entered character falls within the range of ASCII values for digits 48 to 57. So the character 0 is 48. The character 9 ASCII value is 57. And this line checks if the ASCII value falls within the range for uppercase letters A to Z, which is a 65 to 90. This line checks if the ASCII value falls within the range for lowercase letters lowercase a to lowercase z, which is 97 to 122. If the character doesn't fall into any of the above categories, the program outputs that it's neither a digit nor a letter. Just like individual characters, entire strings in C++ are compared using their ASCII values. This is important for sorting, searching, and many other operations. When comparing strings, C++ starts by comparing the first character of each string. If they are equal, it moves on to the next character and so on. Here we have two strings, name1 and name2, initialized with Mary and Mark, respectively. So name1 greater than name2. This is true because when comparing the first different characters, R in Mary and K in Mark, R has a higher ASCII value than K. Name1 less or equal to name2. This is false for the same reason as above. R in Mary has a higher ASCII value than K in Mark. N1 not equal to N2. This is true because Mary and Mark are not the same string. Name1 less than Mary Jane. This is true because Mary is lexicographically smaller than Mary Jane. The comparison stops as soon as the difference is found, and in this case, Mary ends before Mary Jane. This code demonstrates how to determine and display the correct price for a part based on its part number using if-else-if statements. Imagine you are working on an inventory system for a store, and you need to display the price of a part based on its part number. So the part number is stored in a string variable called part num. If the part num entered is S-29A, the program will display the price stored in price A. If the part number enters is S-29B, the program will display the price stored in price B. If the part number doesn't match any of the predefined values, the program will inform the user that it's not a valid part number. The conditional operator is a shorthand way to perform a simple if-else operation. It's particularly useful for making your code more concise. So the format consists of a condition followed by a question mark, then an expression to execute if the condition is true, then a colon, and finally an expression to execute if the condition is false. So we have a x less than 0 question mark, y equal 10, colon, z equal 20 semicolon. So in this example, the condition is x less than 0 is evaluated first. If the condition is true, the expression immediately following this question mark, y equal 10, is executed. If the condition is false, the expression following the colon, z equal 20, is executed. The value of a conditional expression depends on whether the condition is true or false. If the condition in the conditional ternary expression is true, the value of the entire expression becomes the value of the second expression, which is follow the question mark. If the condition is false, the value of the entire expression becomes the value of the third expression, which follows the colon. Due to the precedence of operators, you may need to use parentheses to ensure the correct order of evaluation. This program demonstrates how to use the conditional operator to calculate a consultant's charges based on the hours worked with a minimum billable time. So we have a constant pay underscore rate is the hourly rate, and the minimum underscore hours is the minimum billable hours. Both are constant. The program prompts the user to enter the number of hours worked. The conditional operator checks if the entered hours are less than the minimum billable hours. If so, it sets hours to mean_hours. The total charges are calculated by multiplying the pay_rate by the adjusted hours. The program then displays the hour charges, formatted to 2 decimal places. The switch statement is used to decision making and can be an alternative to a series of if-else-if statements. It allows you to choose from several options based on the value of a variable or expression. The switch statement evaluates the expression and compares it against the value specified in each case label. Each case label represents a possible value for the expression. If a match is found, the corresponding statements are executed. The default case is executed if no match is found among the case labels. It serves as a catch-all in its option. The expression in the switch statement must be evaluated to an integer or an enumeration. It cannot be a floating point number or a string, so either an integer or a character. Although not shown in this syntax, it's common to include a break statement at the end of each case block to prevent fall-through to the next case. If the break statement is skipped or omitted, the program will execute all subsequent case statements until it encounters a break, a feature known as a fall-through. This program demonstrates a simple use of the switch statement. It encodes back the character that the user entered or informs them if they entered an invalid character. So cout, enter A, B, or C, and cin choice. This program prompts the user to enter one of the characters A, B, or C. Then switch choice. The switch statement evaluates the variable choice. Case A, cout, you entered A, then break. So if the user enters A, the program outputs you entered A and then breaks out of the switch. Similarly to case A, the program informs the user if they entered B or C. In the default case, cout, you didn't enter A, B, or C. So if the user enters anything other than A, B, or C, the default case is executed, informing the user of the invalid input. Though the break statements are crucial for stopping the execution once a match is found, preventing fall-through to subsequent cases. The expression in the switch statement must be an integer or evaluated to an integer. It cannot be a floating point number or a string. The values in each case label, like case 1, case 2, etc., must be constant integer expressions or literals. Variables are not allowed. Each case value must be unique within the same switch statement. Duplicated value will result in a compilation error. Including a default case is optional but recommended. It serves as a catch-all for values that don't match any of the case labels. This program demonstrates the fall-through feature of the switch statement, where execution continues from one case to the next unless interrupted by a break statement. So the program prompts the user to enter a TV model number 100, 200, or 300. The switch statement evaluates the variable model num. If the user enters 300, the program outputs this feature and false through the next cases. Similar to case 300, the program adds more features as it falls through to cases 200 and 100. If the user enters anything other than 100, 200, or 300, the default case is executed, informing them of the valid options. So the absence of break statements allows for the fall-through feature, where features accumulate as you go from a higher model numbers to a lower one. So this example shows how to use the fall-through feature effectively to accumulate features based on the model number entered. Here is the program output. If the user enters 100, the model has the following feature: remote control. If the user enters 200, and the model has the following features: the extra feature, which is stereo sound and remote control. If the user enters 300, the model has the following feature: picture in a picture, stereo sound, remote control. And if the user enters 500, the message in the default case will be displayed. It says you can only choose the 100, 200, or 300. The switch statement is particularly well suited for implementing manual-driven programs in C++. It allows for clean, organized, and efficient code. The first step in a manual-driven program is to display available options to the user. Then it prompts the user to make a selection from the menu and store it in a variable, and use the user's input as the expression in the switch statement to determine which block of code to execute. Use the menu choices as the expression in the case statements. Each case corresponds to a different menu options. It is a good practice to include a default case to handle invalid or unexpected user input. So don't forget to include break statements to exit the switch block after executing the code for a specific choice, unless you intentionally want to use fall-through feature. The scope of a variable refers to the region of code where the variable can be accessed or modified. A variable scope is limited to the block in which it is defined. A block is a section of code enclosed in curly braces. The variable is accessible from the point where it is defined until the end of the enclosing block. Variables are usually defined in the beginning of the function, making them accessible throughout that function. Alternatively, you can define a variable close to its first use to make the code more readable and maintainable. This section of code demonstrates the concept of variable scope within nested if statement. The variable years is defined within the first if block and is only accessible within that block. The variable years is not accessible outside of the first if block. This is an example of a limited variable scope. Variables defined within curly braces have local or block scope. That means they are only accessible within that block. In the inner block, you can define a variable within the same name as a variable in the outer block. This is known as a shadowing. When a variable in an inner block shadows a variable in an outer block, the outer variable becomes inaccessible for the duration of the inner block. Although variable shadowing is allowed, it is generally not a good idea as it can lead to confusion and bugs. To avoid shadowing, you choose descriptive variable names and be mindful of the scope where each variable is defined. This program demonstrates variable shadowing, a situation where a variable in an inner block has the same name as a variable in an outer block. Integer number. The program starts by defining a variable named number in the main function. Then the program prompts the user to enter a number greater than 0 and store it in the first number variable. An if statement checks if the entered number is greater than 0. Inside the if block, a new variable named number is defined, shadowing the outer number. The program then prompts the user to enter another number, which is stored in the inner number variable. The program outputs the second number entered, but when it tries to output the first number, the value in the number which is defined in the outer if will be displayed. So this example illustrates why variable shadowing can be a problem. It can lead to confusion and make the code harder to debug. To avoid such issues, use unique and descriptive variable names and be mindful of the scope of each variable.